Now that we can find the probability, the area, if we're given the z-score, let's see how we might find the z-score if we're given the probability. So we'll use the same thermometer example where we have a company manufacturing thermometers. They're supposed to give a reading of 0 degrees Celsius at the freezing point of water, but they know from some sampling that some of them give readings below that, some give readings above that, but the mean is 0 and the standard deviation is 1 degree Celsius, and we have a normal distribution. So we'll note that here. So our mean is 0 and our standard deviation is 1. Okay, so in part A, we want to find the temperature. Okay, now instead of finding probabilities, we're going to find the temperature corresponding to P80. Well, let's recall that P80, then, that P80, that's the 80th percentile. So this is asking us to find the temperature at which 80% of the thermometers have readings below that. Remember, if they're at the 80th percentile, 80% are below that. Okay, and again, because our mean is 0 and our standard deviation is 1, that's the same as our z-scores. So let's see if we can figure this out by looking at a diagram of the normal curve. Okay, here's our 0, and as we've been saying, this is our z-scores, but they also correspond with our x values, just because we happen to have a mean of 0 and a standard deviation of 1. Okay, so this time we're finding the temperature that corresponds to P80. So we want, where are we on this scale down here, where 80% of the other thermometers have readings less than this? Well, at 0, at the mean, we know that 50% or less would have readings less than 0, and then we see the 50% above, right? But we're less than 0 would be 50%. So I know I've got to move more to the right to get my my temperature. It's somewhere over here, right? Somewhere over here is this score. I'm just going to label it with a lowercase a. But what do I know? I know that this area, this time they're giving me the area. That's what we were finding before, but now they're telling me this area, or this probability, is equal to 0.8 or 80%, right? So A is that value. It is the P80, my 80th percentile, but I don't know what that is. So in using our notation, I would say the probability that X is less than some value of A, well, that's the same thing in this case, that Z is less than some value of A, and we know what that probability is. This is what we know. Okay, what we don't know is what A is. And again, we have our technology to help us solve this problem. So we'll pull up our calculator and go to our distributions. And now, because we're going the opposite direction, instead of finding the probability given the z-score, we're going to find the z-score given the probability. So this is the inverse norm here function. So tab down to inverse norm. Okay, and so our area, I'd already entered this, is 80.8 or 0.80, and it'll record 80. Mean 0, standard deviation 1. Let's enter. Okay, so if your calculator is slightly different than this, you'll just put in the 0.8 and parentheses. I'll write this in just a moment, but let's see what our result is. 0.841621. Okay, so what we've done now is we've said we want the inverse norm. And what we're putting in here, I'm going to write it this way first. Area to the left of A. It's always got to be the area to the left of the value you're trying to find. This is a cumulative up from the minimum value to whatever A is. So what we said was that's inverse norm, and this may look more like what you'll enter, 0.8 or 0.80, and that's where I got my 0.841621. Now remember, this is a z-score. This is my A. This is not a probability. Z-scores are rounded to 2 decimal places. So this is approximately 0.84. So now I can come back up here and say, okay, this is where I am at 0.84. All right, this is where that interpretation is important. What have I just found? I want to get this very clear what I just did and have a complete understanding. So let's get the interpretation. Okay, when tested at freezing, 80% of the readings will be less than or equal to 0.84. Or I can say less than, because remember that or equal to is 0 really. So when tested at freezing, %80 of the readings will be less than 0.84. 0.84 degrees Celsius. Okay? This means that 20%, if this is 80%, then this area right here has to be 20% or 0.20, correct? So what that says is 20% would be greater than 0.84, just to make that connection. Okay. Well, let's look at another problem similar to this. Let's find the temperature separating the top 8% from the bottom 92%. All right, so we've got to visualize what this looks like. Sorry about that. Okay. Normal curve. You want to get in the habit of drawing these. Okay, here's my mean. A little better there. Okay. Separating the top 8 from the bottom 92. Top 8. Well, I know that's going to be over here somewhere. Here's 50%, right? And if I want to separate the top 8%, it's somewhere way out here. Okay? So in other words, let me get a different color. This is 8% or 0.08. And all of this other area here, right, from here down is my 92% or 0.92. So I'm trying to find this value here, A. What is that temperature? Okay, this is my Z or my X scale. What temperature is that? Where 8% are higher and 92% are lower. Okay? So again, we're going to use the inverse norm function, but remember, it's important. The calculator is expecting a particular entry. You can't just choose whichever area you want to put in. It wants area to the left, right? So we go inverse norm, area to the left of A. Now, should A be a positive value or a negative value? Well, if 0 is right here, clearly A must be a positive value, a positive temperature. So if we got a negative because we put in the wrong area, that should be, we should use our critical thinking skills and say, wait a minute, I've made a mistake. I was expecting a positive value. I'm to the right of 0. I got a negative. Let me check my work. And that's a good way to test if you accidentally put in the wrong area. So what area are we going to put in? Well, clearly to the left of A is this 92, right? That's what we need to put in. Okay, so we're going to put in inverse norm, and for most of you, if your calculator just requires this area here. It'll just ask you to put in something right here. And we're going to put in 0.92. Mine's a little bit different. Okay? And we'll see what we get there. Okay, what we're finding now is for this particular problem is the probability that x is less than some value of a. That's the same thing as the probability that our z is less than some value of a, because they're the same thing in this case. And that we know is 0.92. What we're trying to find is what is a. Okay. Go to our distribution list. You're going to use the inverse norm. And our area this time is 0.92. And enter. And so this is where a lot of you will just have inverse norm parentheses 0.92 close parentheses, and we get this time 1.40507. Again, this is a z-score, 2 decimal places. So my a here is 1.41. Okay, so our interpretation when tested at freezing. The temperature that separates the top 8% from the bottom 92% is positive 1.41 degrees Celsius. Okay. One more example to help us understand this and to be able to solve all types of problems like this. There it is. Find the temperature separating the bottom 3% and the top 3%. Two different temperatures here. Okay, what would that look like? Okay, the top 3%, way out here somewhere. Okay, so that area is 0.03, and the bottom 3%. So that area is 0.03. Okay, so the normal curve is symmetrical. So if you think about it, we would expect these two temperatures to be the same distance from 0, since they're normally distributed and we're going the same distance. There's the same amount of area left here. Let's talk about that. What the total area here, or if we consider half of the area is 50%, so this area would be 0.47, this area would be 0.47. There's our 50% on this side, 50% on this side, and of course that total of those two would be our 94%, right? Okay. So, because this is symmetric, we expect these two to be the same, and they'll actually be opposites of each other. So I'll label them, this one, let's see, get another color here. I'll label this one A and this one B, but for example, if B is 2, then A would be -2. Okay, we don't know what they're going to be, but that's just an understanding what we're seeing here because of this is a symmetrical graph. Okay, so to find the area here, to find A, we know the area. We want the, on this one, we're looking for the probability that X is less than A, which is the same thing as the probability that Z is less than A. And we already know what that is 0.03. So the question is, what's A? And we know that A is a negative temperature, B is a positive temperature. Okay, so for A, we would do inverse norm, area to the left of A. To the left of A is 0.03. Okay, so go to our distribution list, choose inverse norm, our area is 0.03, whoops, enter, 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 okay, and we get negative 1.88079. These are z-scores, 2 decimal places, negative 1.88. Okay, so A is equal to negative 1.88 degrees Celsius. Okay, now, as we said, we would expect then for B to be what? Positive 1.88 degrees Celsius. But I want to show you how you would get that for sure. You know, if you want to check it, let's look at what we would do with the inverse norm then. We would say, well, for probability that X is now less than B, because we can only do this less than, right? Z less than B. Well, what is that? What's the probability of less than B? It's not 0.03, that's greater than B. Less than B. All this is less than B. So it would be 1 minus 0.03, or 0.97. That's all of the area less than B right here. Correct? Okay, so let's put that in our inverse norm. Area to the left of B. Distribution list, inverse norm, third one down, 0.97, enter, enter, that's correct. Notice we get 1.88079, same thing we got before. We're looking for a z-score to 2 decimal places. We got our positive. Now, in my opinion, this part isn't necessary if you understand the symmetry of the normal curve. You just get one of them and you know the other. 1.88 degrees Celsius. Okay? Not expected that you would have to do all of these calculations if you understand that. So, our interpretation on this one, when tested at freezing, when tested at freezing, 3% of the thermometer readings would be equal to or less than negative 1 point, or we can just say less than, would be less than our negative 1.88 degrees Celsius, and 3% would be greater than. Okay. Again, I want to stress these interpretations are important. There's more than one way to write them. There's certainly, you could say this same thing with using, a different sentence, as long as you're saying these same things. But it's important to be able to summarize in a sentence or two what you just did. It shows your understanding of what you did.